so little is known that they can almost get away with that, because it's a huge statement. And it's like, well, you already told me these things are impossible and they exist and they're demonstrable. So why not that? Well, because that's not scientific. That's a theory shellacked onto the math instead of the math speaking for itself. Right, and the chip speaking for itself. So the chip doesn't need alternate universes to operate this fast. It just needs good, coherent quantum entanglement and cohesion and time to do it. And time for them is very relative. Time for a quantum computer, it can do a lot in a very short amount of time. So let's not lose the breakthrough for the hype over the universe thing.
Hey Joe, how you doing, brother?
Hey man, how are you? Good to see
Doing
you.
good. Good to see you too, man. Um, so there's this story going around about the quantum computer, um,
Yes,
and I knew there was only one person I could talk to about it.
I
So
am
first of
flattered.
all, what is quantum computing?
All right, things get really weird really quickly, even without this parallel universe claim that is coming out. Um, all right, to understand quantum computing, we'll step back into like regular computing just for a quick second.
Okay.
The whole basics behind computing are zeros and ones, right? Something can be a zero or something can be a one, and the basics of all computing, right? So if you think of it as the smallest, like the atom is the smallest, thing in matter, the smallest data thing is a bit, right? And a bit can be a zero or a one, right? In quantum computing, you don't have to be a zero or a one. You can be both at the same time. And that enables all of this insane computing power and processing power in times, where they can do billions of things that would take millions of years, they can do in minutes, right? A normal computer can't do that. And the reason that can work is because of the qubit, the quantum bit. The quantum bit can be a zero or a one because it doesn't have to be either. And that this is when it gets very, very strange. This this quantum bit, one of the things that these things can do is become entangled with another qubit, so that if it changes up or down, it's zero or one, it'll automatically change the other one, no matter what the distance and no matter how. And it'll happen instantly. You don't have to watch it. You just know it happened. So it's like, have you ever seen the movie Prince of Darkness?
No, but I know what you're talking about.
It's a John Carpenter movie of dubious worth, but it's like the greatest screenplay because it blends spiritualism and religion and quantum physics and all. They have all kinds of really cool things. But one of the lines in the movie is that you know conventional logic breaks down at the realm of the subatomic particles. That their relations don't make conventional sense. So how can human beings harness these spooky relationships into something practical? And computing is definitely the answer for that. And quantum computing is the next huge step. Everyone's going on and on about AI, and there's certainly some validity to it, not justifying the hype, but quantum computing does change everything immediately. So the limitations are keeping quantum conditions. If you want to keep a qubit in any kind of stable condition, it usually requires something like keeping it at a below zero temperature or very sensitive conditions, right? To keep these things pristine. If you have them doing things, running operations, they're going to lose their what they call coherency. They're not going to relate to each other as clear, and they're going to introduce errors. And if you get errors, you can't trust your computations, and you lose your ability to compute at these levels. So that's the big problem to solve, and that's what seemingly Willow does solve, at least to a certain degree. And that's a big deal, right? None of this has anything to do with other universes, right? None of this. And I don't think any of it actually does. but we could get into that. But I'm going to take a pause to see if your brain is melted, if any of this made any sense, or it makes sense, but then you realize that it's not supposed to make sense. It's all Schrodinger's cat. It's the realm of the spooky subatomic particle, where logic does break down. It's crazy stuff. It honestly is. But all that is the current state of the art. It doesn't get weird until this guy stands up on stage and starts talking about parallel universes. So,
sorry, let me let my dog in. Go ahead. Yeah. So my brain was already melted, but yeah, it's more melted now. So the calculation of the amount of time it would take, like you said, that a quantum computer can make a calculation like that would take an older or a different computer like millions of years. How do they make that calculation?
by doing calculations. They keep them stable long enough to be able to do things with them. I mean, this isn't a hypothetical thing. These are actual quasi-physical things that
Yeah.
are operating in labs and inside computer chips. I mean, they know because they do it, which is the cool thing. And that's demonstrate. They can demonstrate it. They can repeat it. It stands up to scientific rigor. That paper in Nature is not being attacked. What the guy said on stage is being attacked, but their achievement is not. So it's part of the communication problem. Why they're going down this other Art Bell road when they don't have to is sort of beyond me. But because the actual achievement is worth noticing, and it is a milestone. In terms of what they're saying, when you look deeper into what they did into the paper in Nature and everything, usually when you build a lattice, a network of qubits to relate to each other, you lose coherence. You just do. And they're figuring out architectures that don't lose as much coherence. That's a big deal because these chips become very, very useful because they're more stable. And you can't put anything out into the market until you reach that milestone, and they have. So that's a big deal. So it again, they know they can run that fast because they run algorithms that fast, and they run equations that fast, and they throw problems at them, and they know the speeds.
So how is quantum computing different than AI?
Oh well, there will be crossover, which would be interesting to talk about too. But AI is the way that is machine learning, how the machine learns. So no matter what kind of machine it is, really, if it's running in quantum or standard, it's the way you train it, and then how it reacts to that training without you having to program it. So it's adapting. It's adaptive computing. This will enable these systems to adapt even more so, right? So something that
Gotcha.
would take a quarter of a second would take even less, and that's a big deal when you're talking about cars, anti-car, collision. If you're talking about AI and air traffic control, if you're talking about, space, that very precision things where lightning fast decisions need to be made. Human beings used to be the only things trusted to make those decisions, while now we're actually second best at them. You'd be safer with an AI quantum pilot, in theory, than with a human because the error rates would be so much lower.
So is it fair to say that quantum computing, that's like the operating system? Is that
I don't know.
okay?
No,
Sorry, I'm
probably
asking you
not.
like ape questions, like very basic questions.
Yeah,
But
yeah,
it's helpful.
I no, probably, but
Okay.
maybe on some way. I mean, I could torture it either way. I'd rather just ignore the question.
Good answer. Um, so what are this is going to help with everyday life, space travel. Um, what are some of the other applications?
It really is sort of limitless. I always think implantable and wearable electronics. Everyone actually the first app we should talk about the first applications, which won't be the everyday stuff, but medical research. Being able to explore every option conceivable option when you're trying to put together molecules to make new medicine is huge. And to be able to do that in a couple of minutes it is amazing. So, processing huge volumes of data will be a lot easier as well. So that's why I think the AI crossover is very interesting too, because they'll be able to learn a lot faster. So, um, other application, I mean, they're really, it depends on the price point and it depends on the dependability, right? So if they really make a chip, think of everywhere there's a silicon chip and replace it with something that is, I don't know, 3 or 4 hundred times stronger, 1,000 times stronger. Um,
Wow.
and then think of what that would enable. I mean, what your phone can do at that size really is dependent on your screen. But, if you have something embedded so you see it in your cornea, you're going to be able to process all that information in a chip that would fit in your eyeball. I'm just spitballing here, but I mean,
Yeah.
but go ahead, like take that anywhere. Take that concept and blow it out to anything that's in your life, and that's where it'll be. That's how ubiquitous it could be. It's not there yet, but the um, weather will probably might be another. That's another huge data set. I like astronomy for this too, but it's not like they're throwing huge amounts of money around. But that's a great application. So anything that takes huge data sets and crunches it in to seconds worth of processing, and it would have taken a supercomputer to do it. Testing nukes, they always seem to get a seat at the table because that's a huge data thing, and they've been doing that's the replacement for actually physically testing them. So it gets sort of bipartisan kind of support. So there'd be money for that. Think of just big data sets, and that's where you'll find it. And then if it gets popular, cheap, and reliable, it'll be in your phones and your pacemakers.
So the original, the finding, the article in Nature, you said, right, was where the finding there is that quantum computing can make calculations that are like far exceed what we've experienced up until this point.
But their findings are that they can keep the coherency high,
Gotcha.
so
Okay.
that it's a lot more reliable. So the error rate goes down, and that's the evolution of the thing. That the error rate has to go down for these things. That's been the problem, is stabilizing their operating conditions enough so that they can do their thing reliably. And there, it gets really, it gets actually above my pay grade a little bit. I don't understand how their architecture works at this point. I've read enough, but it's really genius level type stuff. It's amazing, and it's hard to describe because you grope for these physical and logical sort of connections to make an examples. Oh, it looks like a bridge, it's a highway, the information superhighway, data pipelines, and all this. But you get to the quantum, and it gets spooky, right? It doesn't make sense that particles shouldn't become entangled, right? It doesn't make sense. There shouldn't be that connection, but there it is. And we can use it. We don't understand it worth a damn, I don't think, but we know it enough. We didn't understand gravity. We're using that too. I mean, it's not the first time, but it's just interesting. These are very spooky forces that we're tapping into.
Yes, I don't even fully understand the one, and it can be a one or a zero or a one
Yeah,
and a
if you understand it, you don't understand it. I
gotcha.
mean, that's just the thing. I mean, if you flip a coin, no metaphor helps. I'm
Yeah.
telling you. There's two things that are almost mystically connected. It's easier to think of it like magic. They were created in a way that 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 connected them, that entangled them. It's almost romantic, right? That in such a way that no matter what the distance, when this one is in the up position, this one will be in the up position, and you just know it's always going to work. It's endlessly repeatable. The coherence goes down. So as you try to make that phenomena useless, but the phenomena exists. It doesn't make sense. things that are separated by a million miles that don't have a physical connection, that move, that change their position, shouldn't affect the other, but they do.
Yeah.
But they do. That's not the part about this that I'm calling BS on at all. It's the other worlds part that I don't believe in terms of this. I believe that, mathematics, I don't know, I have problems with the other worlds theory in general, but in this particular, I don't think it proves jack.
Can we start with your problems or with your issues with the other worlds theory and then talk about the how it relates to this?
Uh, yeah. Well, no, I'm not going to.
Okay. Okay. Gotcha.
And the
Gotcha.
reason the reason why is it might be easier to sort of back into it with what we were just saying, which was
Okay. Cool.
superposition, which is the ability of an entanglement. The idea that these things are that that these things exist and can influence each other at an infinite distance, um, without any sort of connection, right? That idea has spawned the other worlds theory, or as not that's not true. The Greeks, ancient Greeks were talking about that, but has given some mathematical teeth to the idea that if something exists in two states at the same time, then there must be a branch in the road where it decides up or down. But what if it went the other way, right? So if it exists in the other superposition, then it's got to be in another universe. It can't be in ours because you can't have something that's two things at the same time, basically, right? So, so I have a problem with that. I mean, I don't understand what's happening, but I don't think that every single millisecond there's an infinite number of infinite worlds being created at every juncture because that means everything is superpositioned somewhere. I mean, it's not like there's your antiparticle. It's not like there's your Spock with the goatee in the evil universe. There's an infinite number of universes, right? Because every second there's another superposition that's been created and another fork in the road that goes down. It's impossible to envision. And even if it was true, if it's that pervasive, what difference does it make? Right. And they would say the difference is you can tap in to those other universes while you're making calculations. That's why we can do something so much faster because it's happening in multiple universes at the same time, delivering that result. And that don't I think that they're delivering that result because of why quantum computing is worthwhile to begin with. Um, it, so little is known that they can almost get away with that, because it's a huge statement and it's like, well, you already told me these things are impossible and they exist and they're demonstrable. So why not that? Well, because that's not scientific. That's a theory shellacked onto the math instead of the math speaking for itself, right? And the chip speaking for itself. So the chip doesn't need alternate universes to operate this fast. It just needs good coherent quantum entanglement and cohesion and time to do it. And time for them is very relative. Time for a quantum computer, it can do a lot in a very short amount of time. So, so it, let's not lose the breakthrough for the hype over the universe thing. It's almost easier to envision the alternate universes at first than it is the basics of quantum computing. So once you get past that one ghost, weird, freaky thing, and then you're hit with this other one, and then you're forced to say, well, that might be an overreach. So they're not doing quantum computing any favors by going on and talking about parallel universes.
So is there a little bit of it that's just like spectacle?
I think so. I think it's a little bit of tech girl
Sorry.
marketing. I think it's something that they talk about internally, and he brought it external because he thought it was so cool, and it is. But it brought up brought up. It's all the people are talking about. We wouldn't be talking about it. So maybe that's the goal, right? When you reached out to me, it wasn't about quantum computing because these breakthroughs have been done long before. It wasn't even about Willow; it was about parallel universes. So it does work, you know. And there is sort of an arms race when it comes to quantum computing, just like there is one with AI. I mean, between companies, between countries, between militaries, between institutions. I mean, it's pretty pervasive. So yeah, getting attention to it's a big deal. But people would have paid it. People in the know would have paid attention to Willow anyway. So that's the part where I'm sort of, not so enthused at the way that they rolled it out. But I'm psyched for the team. I mean, what they did, the engineers did a great job. The marketing people let this guy kind of run amok, I thought.
So he was involved in the study, and then he started kind of positing these ideas.
Yeah, I think that's the yeah. He said, we may have even as part of the presentation, it was we did the milestone breakthrough. Here's how we did it. We may have even tapped into other universes, and he talked into why that would be a possibility. And it was like, why? Why would you
Yeah.
do that? Why did you have to go there? It's not an era of restraint, but when you have a winning hand, you should just let it play out.
So what should we expect, like like over the next year? What changes should we see?
Well, they still have a while to go before prime time. Um, I think it's for Willow, it's incremental. It's increases in coherency. It's fine tuning. I think that, and I know that because that's what they said. Uh, it's a breakthrough though. It's something to build on, right? And it's definite progress. So that's the next level. And what you do at the next level is you build on it more. It's like building an airplane. You got to expand the flight envelope. You got to have it do more efficiently, more reliably, so that you don't need a test pilot. You just can let it run itself. That's the next year. That's the next 10 years, probably the next 30 or 40 years. There's a long way to go, which is exciting. That's why a breakthrough like this is it's even more important when these technologies are younger. And this is a very young, impactful technology, but they're up and walking now, toddling, but they're up and walking, and they're going to be, they're going to grow fast, and there's not going to be a lot of walking. They're going to go from crawl to run, just by their very nature. So this little velociraptor, quantum computers are coming. They'll end crypto. They'll end all cryptographic systems are going to be compromised. They're going to make every phone and computer in the world outdated. And that's just round one. That's before commercial development. So, yeah, it's going to be an interesting run.
Tell me more about the crypto thing, because when we were texting, that's what you kind of struck out as like, yeah, I think this is probably the real story, or a big part of the real story.
Oh yeah, just the impact on well when you think of what crypto is and what it's based off of and the bit keys and all the rest of it, you're basically saying if you got a random lock and spun it, how many times could you do that before you eventually were able to open it? In a computer can do that, a lot more quickly than a human could do, right? So, but how do you make that so big and complicated that it's unbreakable, right? That's one of the basics of all cryptography, including cryptocurrencies and everything, which they go to that other level that we won't have to. But if you just think about that basic security premise, right? I mean, crypto is revolutionary because of the blockchains and the rest of it. But if you don't have the essential security built in, you got problems, fundamental problems. So, because the whole blockchain is dependent on the integrity of that recorded process, where it came from, how who owns it, all that. So, if you have something that can spin a billion locks a billion times in a billionth of 1 second, you don't have crypto. You don't have any cryptography anymore. It's done just like that. So so national security implications are enormous, right? Just huge. And everyone says, "Oh, the nuclear codes." Our ICBMs are so old; they're in tunnels. The tunnels that have the cords in them that activate it, they're literally hardwired in. They're like, you can't hack an ICBM because they're so old, not because they're so secure. They're almost like air gapped. So it's interesting. But anyway, yes. So yeah. So then you pair it with AI and throw a little of that into the mix, and you can get some real nightmare or utopian scenarios together. But crypto doesn't survive. They just can't. I don't think. No one thinks. Crypto people don't like to talk about it, but it is the Armageddon that's coming for all of that.
How far away is that Armageddon?
Well, thanks to Willow, a lot closer. Um, I don't know. Because the development of quantum is so new, and it's hard to it's hard to back it because of all of the, I don't know, just the steep hills it seems like it would have to climb, the usability of it and the stability of it. But they have a chip. It works. It has good coherence. It's something they can build on. It's an actual architecture they can start designing around. And that news like this makes me think it's a lot sooner than we think. And it doesn't take very many. In theory, one quantum computer that was aimed at a crypto system would be enough to ruin the whole thing. So if one quantum computer aimed at Bitcoin could ruin it in less than a minute, probably less than a microsecond if they really wanted to get into it. If they dedicated, if there was a hacker that wanted to do that, I don't see what would stop it.
So does this also push us forward to like the very Hollywood version of a robot controlled Armageddon?
Probably, yeah. Everything seems to. But yeah. I mean, it certainly makes that dystopian future a lot more likely, right? I mean, I don't know about there's a certain inherent a morality play that the computers learned enough to know that we're the enemy. And it's sort of like, I don't know, I'd like the machines would think that we're here to tend to them. And they got a good symbiotic relationship going with us, whether we're the barnacles or they are, it's up to them to decide. But I don't see the extermination being the way forward for machine kind. You know, um, it doesn't make a lot of logical sense to go down that route. So why would they?
I like that.
So I don't believe
That's
that the humans are so bad that we deserve that. We're horrible. But I
yeah.
mean, I don't. That was this like 1960s, 1950s. We deserve to get the bomb dropped on us kind of thing. And it's like maybe it'll go the other way. And maybe we've learned enough from animals and our relationship with animals that will treat robots marginally better. I don't know. Maybe we'll need them so much that they'll need us back because that's their prime directive. I mean, why not let the robots' imagination wander the other way too? Because it could go that way just as easily. More people's lives get saved by drones than are killed by them. Excluding Ukraine probably, but in the world, like the net good from drones is higher than the other. Same thing with satellites. I mean, our record as a human race is getting better when in terms of like responsible use of technology, not worse. And when we screw up, or at least feel bad about it and try to hide it, which is its own kind of progress. Shame as a metric for human progress.
Yeah, that's a good line. Yeah. Um, what else are you hyped about right now in tech?
You know, I haven't been in hype mode very much. I'm working on at least one art magazine article on spaceflight, and I'm just waiting for the new NASA direction to happen, the new administrator, the new, so horrified, I don't know. I have no information. No one has any information on what's going to happen next. So as a feature writer for magazines, that's a real pain in the ass, what to plan around. Like this could be a great story. This could be a positive story, negative, good for Houston, good for NASA, good for private space. We don't know. We don't know. So, we'll see. I mean, if he's going to move the headquarters to Houston, what does that do? Can he do any of this stuff? How much of it is just hype and smoke, and how much of it is, yeah, that's discretionary and that can go there. What does Congress have to say? What does he have to do to buy off Congress? Buying off the Texas delegation is pretty easy with spaceflight. If you give them headquarters, they'll probably let you cut Artemis. Yeah, maybe. Yeah, but that's the level of like we have no clue of what's going on. And that's everyone. I mean, I'm talking to analysts, I'm talking to private space companies, and talking to all kinds of people. No one has any idea. So how do you plan ahead for that? A feature that's due at a certain point in the year. So the uncertainty is real. Changes might not be, but the uncertainty certainly is. So that's the shock and awe phase of the administration, I guess.
So, is there anything else people should know about quantum or other worlds theory, multiverse, anything like that?
Probably not. It's probably better you just ignore it until it's here. It's just to me, it's just another example of something that we'll never be able to fix on our own when we get it. We already passed the big inflection point where we can't fix our phones, we can't fix our cars, we can't fix our sewing machines, right? You need to be an electrical engineer and a computer science major to do anything. So, and they're trying to do that with houses too. Smart houses are going down that road as well. Although you still need a good plumber. Anyway, so what you should know is that just don't trust everything that you read. This is a good excuse to talk about quantum computers and some of the more interesting and far out things about it. And the alternate worlds theories as well. I mean, it's all good to explore. Just watch out what you believe. You know, Science is tricky.
That's great. Man, it's good chatting with you.
Always, man. Whenever you need it, I'm around.